Okay, so we just talked about how to tell if we have discontinuity by looking at graphs and what types of discontinuity there are. Now, what we're going to do now is talk about continuity. So at this point, we know there's actually rules for continuity, but here are three conditions that must be satisfied in order for a function to be considered continuous. So there's three steps. So first off, before we even get to those steps, we have this going on. If we're going to let x equal c, so whatever the value of c is, so if we're talking about if the function is continuous at x equals 5, c would be considered 5. So x equals 5, so c would be considered 5. So here we're going to say f of x is continuous if and only if these things happen, which is going to happen underneath this. These are those three conditions that must happen. So first off, come back. F of c must exist. So in other words, like we said earlier, like a few seconds ago, if x equals 5, if we substitute 5 into this function here, that means that it has to actually have a value. If it doesn't have a value, that means it doesn't exist. We stop there and it's not continuous. Right? If step 1 is satisfied, where we have a value for it, like it does give you a number answer, a numerical answer there, then we go to step 2. And in this part, we say, okay, the function approaches the same value, y, on both sides of c. So again, c is that number, like for example, we said 5. So we're looking at from the left side and from the right side of c to see if it gives you this, if it approaches the same number for the letter c, for the number c, sorry. So with that, we're going to take a look at our limits and actually help us look at that and understand. All right, so with this, to bring in our limits here, and again, this is just to be the preliminary look at it and work out and talk about it a little bit. What we are going to say is, for this first part, as x approaches, so the limit of f of x as x approaches c from the left side. So if we have that negative symbol right here, that means we're talking about coming from the left side. So that's just the terminology. Whenever you see that, if you see a number with a negative up top like that, that means you're coming from the left side of the graph. So again, it says this means x is approaching c from the left side. That's all it's saying. For the right side, we have a plus sign here. So it's the exact same thing as this one here, but instead of having the subtraction or negative sign there, we have the addition sign. So this says x is approaching c from the right side. So the plus sign means from the right, that's the positive side of the graph. The negative there is the left, which is the left side of the graph. The negative numbers are on the left side of the graph. Makes sense, I hope. All right, so we find those values. We find out where those values are, or what they are. So when we find the value for the negative, we find the value for the positive here. If they equal each other, that means that step 2 is satisfied. So they have to come from the same side. We're going to use tables for this to look at it, but as we're going from the left side and going from the right side here, looking at the limits and everything, if they both equal the same number, that means step 2 is satisfied. So if step 1 exists, that means step 1 is satisfied. If these go to the same number, that means that is satisfied. So then step 3 is, if step 1, the answer for number 1, step 1, and the answer for step 2 are the same, if they equal each other, that means it is a continuous function. So this means it is a continuous function. At x equals c. So at this point, again, whatever that value is that we're dealing with, if it's 5, that means it'll be continuous at x equals 5. If it's 2, it's 2. If it's 1, yeah. So if these 3 steps work and they all give you the same numbers each time, that means it is continuous at that point. Okay, so with that, and as you go into calculus and stuff and do all the other stuff, we'll talk about continuous at other points and every other places and everything, and it'll be cool. But this is just what we're dealing with right now in pre-cal. All right, so here we go. Let's go to example 2.